All right, so let's work out this problem. Would you expect sodium or magnesium to have the greater first ionization energy? And which should have the greater second? So it's a two-part problem. So the first part is saying Na compared to Mg, and I want to know about the first ionization energy. The second one is Na compared to Mg, and I want to know about the second ionization energy. So if I want to know the answer to this, based on my rules, I have to know where that electron is. Is the electron in a filled, a half-filled, or a partially filled orbital? So the only way for me to know where that electron is I need to write out my electron configuration and draw my orbital diagram. So let's do that for sodium and for magnesium. So I want to be able to do my electron configurations for sodium and for magnesium. And you could do the shorthand. So for sodium, the shorthand noble gas would be neon. Then it's 3s1. Magnesium is neon 3s2. So now I want to think about what's the orbital look like. So let's draw an orbital diagram. So for 3s, it's a one line, because it's an s orbital. S orbitals have only one line, and I draw one electron. For this 3s, still an s orbital, one line, but it has two electrons. So let's talk about their status. So that first ionization energy is taking one electron, my first electron away. So for here, this electron that I'm going to take away, because he's the outside, he's my valence, he is in a half-filled orbital, because the S can take, if every orbital, every one of these lines can only take two. So he is half-filled. Okay? Let's look at him. He's got two electrons here, so he is completely full. So he is filled. So which one is it going to be harder to remove an electron from? A filled orbital or a half-filled orbital? Remember I said, based on our rules, that filled and half-filled are harder to remove than partially, and that filled is harder than half-filled. So for us, since sodium is half-filled, magnesium is filled, the magnesium is going to be harder to remove from the sodium. The magnesium is going to be harder to remove from the sodium because he's a filled orbital. So it's going to be harder to remove this electron than it would be from that electron. All right. The next part of this problem wants the second ionization energy. The second, okay? So let's look at where I was here. So this was the first ionization energy. The first ionization energy was taking this electron. So I was taking this guy right here. And so I'm taking him out. I'm removing him. So that means for what would be left would be just neon. Just be neon. And if I took here, I'm just taking one of these guys. So what's left here would be neon 3s1. I would just have one electron left. That's what's left after I do the first ionization energy. So now if I do a second one, I want to talk about, well, which one's going to be harder? So this guy, let's talk about what he is. He's here, he's neon, which means his 2s orbital is completely full and his 2p orbital is completely full. And remember, he's a noble gas, so he really doesn't want you to remove. So he is full, he is happy, he really doesn't want you to remove an electron from it. Now, once I remove the first one, now this orbital is only half full. He's not full because I already took one away. So after the first ionization energy, now he is half full. So when I'm talking about the second ionization, he's full. He's half filled. So for the second ionization energy, because he's full, sodium is going to be harder to remove than magnesium. So all that matters here is you have to look to see what is the status of the orbital where I'm taking that electron from. If I'm taking it from a filled, it's going to be higher than if I'm taking it from a half filled. Okay? So you need to draw the pictures. The only way I could do this is write my electron configuration and draw my orbital diagram so I could see, is it full, half full, or is it full when I take the first one, and then I can also think about the second ionization energy. All right, so ionization energy, this guy, is if I'm removing an electron. Now we're going to talk about the opposite. What if I'm trying to gain an electron, give an electron? And that's going to be our next lecture.